Everybody. Today we are discussing the next model of the nucleophilic addition, that is the Felkin Ahn model. In the last class we have discussed the Cramp's rule. In the Cramp's rule, the large group is anti to the carbonyl group, and I have shown the Cramp's rule in the bottom of the slide. Here we can see that the large group, I have represented the large group as L, and which is perpendicular to the carbonyl group. So the carbonyl group is flanked in between the small and the medium group. But here we can see that a steric hindrance is existing between the large group and the R group. So in order to avoid this steric hindrance, the scientists proposed the new model, that is the Felkin Ahn model. So in the Felkin Ahn model, the large group has to be the perpendicular to the carbonyl group. So I have shown the Felkin Ahn model like this. So here again we are adding the nucleophile to a carbonyl group, and this carbonyl group is attached to a chiral center. So as we proposed in the Cramp's rule, we have to assign the substituent which is present in the chiral carbon atom as medium, large and small, and which is connected to a carbonyl group. So since we know that the carbonyl group is sp2 hybridized, the molecule is a planar structure, so the nucleophile can attack on the top and bottom of this plane. And according to the Felkin Ahn model, we have to write the starting material in the Newman projection formula. All the remaining other things are the same in the Cramp's rule, but only the difference is that the large group is perpendicular to the carbonyl group like this. Okay, I have shown the molecule in the Newman projection formula, and the molecule which I have shown in the top is the representation of a Felkin Ahn model, and we have, first of all, we have to represent that molecule in Newman projection formula. So while we are writing the Newman projection formula, and according to Felkin Ahn model, we should write the large group is perpendicular to the carbonyl group. So we can write in two ways. Either the large group is in our right hand side or the large group is in our left hand side. But in the first Newman projection formula, that means the large group in our left hand side, the right hand side, the R group is just behind the small group. So we can avoid the steric hindrance here. So that is the most favorable Newman projection formula or the configuration for the nucleophilic attack. So the nucleophile almost attack in the smallest group side, so that means the nucleophile attack just opposite to the largest group. Whereas in the second Newman projection formula, here the large group is in our left hand side, so the left hand side, but R group is just behind the median group. So there is a greater steric hindrance is appear. So that's why the Newman projection formula, which is indicated by the green one, is the most preferred Newman projection formula for the nucleophilic attack. And nucleophile approach from the opposite to the largest group. This is the Felkin Ahn model, and this is the most favorable model for the nucleophilic addition to a carbonyl group which is connected to the chiral center. Now this is also an asymmetric synthesis, that means the product are produced in an unequal amount, then we call it as asymmetric synthesis. So here one of the configuration of the product is predominant, that's why we call it as asymmetric synthesis. And here also we are creating one chiral center, we are creating a new chiral center, that's why it is known as diastereomeric compound, because if you are creating only just one chiral center, we will produce an enantiomeric product. But here in this example, there is already a chiral center is there, and we know the configuration of the chiral center, that is fixed, and we are creating an additional chiral center. That's why there is a change in the configuration of only one chiral center, that is the newly generated chiral center. For example, if a chiral carbon atom is attached to a carbonyl group and if the configuration of that chiral center is R, and by the nucleophilic addition a newly generated chiral center is formed, and suppose the configuration of that chiral center may be S or R. So our configuration becomes SS or SR. So there is a only change in the one of the chiral center, configuration of the one of the chiral center. That means the product generated due to the nucleophilic addition is diastereomers, and the phase is diastereomeric phase. I hope that you understood the Felkin Ahn model. Thank you.